Hello everyone. Today we are going to do a session again on LR and data interpretation. It will be a mixed bag, and for a reason I believe that today's session is going to be extremely important because I've got a lot of students telling me, Sanjeev sir, what do we do with some topic like this which is mind boggling half the times, and we are not able to grasp, simply because we are scared. But this topic is so easy that we're going to take within LRDI, the particular set of questions that we're going to take. It's so easy, and it's so much to enjoy, that, trust me, all of you will love to do these topics. Just a little bit of getting used to it, and I hope by the time we end up doing a couple of caselets, you will be good with it, and then we'll take a few more here and there, and you will see that there's a method that with which we can start approaching this particular topic. But what is the topic? You guys must be wondering. I'm saying so much about the topic. What is the topic? So I believe one topic which a lot of students, like I said, a lot of students will come to me and ask, Sanjeev sir, what is the topic that you think would be a decider, not that would come in CAT, that would be a decider in our confidence level while handling questions on LR, If we are good with this topic, what is the topic that we should probably be good at? So there are two things that I normally say you've got to be good at, One is something that we call games and tournaments, This is pretty important. It's a significant topic. It has come in several CAT papers, That makes it extremely important. The second, questions based on sliding rule. Now the sliding rule, I've done so many questions, and in fact there are more questions coming up. Every time there's a sliding rule, I let you know what's a sliding rule, and I'll tell you why this question is based on sliding rule. Now, even in games and tournaments, you can have the concept of sliding rule, If you're comfortable with these two, does not matter how difficult the question is, you should be able to solve all logical questions, in CAT, The exception, the only exception that I say you might not be able to solve with these two things, that is your set theory, There's the only bit which might not be connected with these two topics. So you can have questions on set theory with games and tournaments, But this is something that might require a different bet altogether. And if you're comfortable with set theory, that's crazy. If you're not, I would say, get comfortable with it. That's also something that, I consider. So if I look at any paper, assuming that I give CAT this year, or I give CAT sometime, actual CAT paper, the ones that I would look at attempting as a student would be these three, This, by the time I look at these three cases, I would easily find two or three good questions based on these three cases, and they would be the more logical ones. They were, These are the best possible cases that you can get in any examination based on these three things: the games and tournaments, questions based on sliding rule, and sliding rule can have questions in literally everything. It could be on seating arrangement. Sliding rule could be on input output. Sliding rule can be on several other topics. We've done it in classes: truth and lie, binary logic. So many things can have sliding rule, and of course set theory. Okay, without further ado, let's start with today's session. We'll go to the questions, but today's session is more or less on games and tournaments. Let's take about a couple of caselets and try to work on these caselets beautifully, so that we can get a hang of what we could do with games and tournaments. So let's take the first caselet. In the first caselet, what we'll do is we'll try to together solve it, and thereafter we'll take one by one the questions. One by one we'll try to take the questions, and we'll try to work out the cases. So let's start. So let's read the question together. You can read with me. The following bar graph gives the percent distribution of time spent by different competitors on swimming, biking, and running in a triathlon meet. C won the competition by taking 240 minutes to finish the event, while the third, fifth, and seventh position was occupies. Okay, these people occupied B, F, and D, taking 320, 420, and 560. That should be minutes respectively. Also, B took more time than G. H took more time than A, and A took more time than E respectively to finish the event. No two persons finished the race at the same time. That's beautiful. which means, right? Now, let's look at the question first. Thereafter, we'll look at the entire case. So we have a case. There are 8 people taking a participating. We know the rank 1 timing, the rank 3 timing, the rank 5 timing, the rank 7 timing. Very less data, but there are 4 questions. Who came fourth in the triathlon competition? That's the first question, right? We have the second question. Who among the 8 competitors is the fastest swimmer? Right. The next question. Who among the 8 competitors is the fastest runner? Amongst the fastest runner, and who among B, F, A, and D took the second highest time in biking? Right. So let's begin. What do we say with the first one? Right. So now we understand that C won the competition, and C won the competition taking a time of 240 minutes. Right? C won by taking 240 minutes. C has come first. C has come first and take 240 minutes. Right? The person B is come third and has taken 320 minutes.
Press the bell icon on the YouTube app and never miss another update.
The person F, the participant F, has taken 420 minutes and has come fifth, while the person D has taken 560 minutes and has come 7th. That means all the odd number ranks are present with us, all the even number ranks are not there. And when we're talking of these ranks, it's overall rank in the meet, not the rank on swimming, not the rank on biking and running, right? It's an overall rank in all the cases put together, right? Now, we must have a rank number, we should be placing somewhere a rank number 2, a rank number 4, a rank number 6, and a rank number 8. So let's look at what we are doing. B took more time than G. They say B took more time than G, which means what? B's come third and B is taking more time than somebody. We know B is already taking more time than C. That's why C is number 1. But B is also taken more time than G, right? Which automatically means G is taken lesser time than B, which means B should be a better rank, either rank 2 or rank 1. Rank 1 is taken by C. So G should be taking a rank 2. G should be taking a rank 2. And this case, we don't know the time, so it will certainly be a range. The range of time taken by G would be between 240 and 320. Now, how did we arrive at that? Because the rank 1 is taking 240 minutes and the rank 3 is taking 320 minutes. So G could be any value between 240 and 320. Now, if you look at this graph, this percentage chart, right? We have a percentage bar chart. Here, if you notice, there is 12%, 80%, 8% for H. Or for G, let's consider, there is 20%, 18%, 62%. So what does it mean? That means out of the 240 to 320 minutes, the total time taken by G, 20% would be spent on swimming, 18% of that would be spent on biking, and 62% would be spent on swimming. Likewise, if you take for, C, the person who stood first, right? If you take for C, 42% of 240 minutes would be for swimming, 14% of 240 minutes would be for biking, and 40 to 44% or the rest would be for your running, right? Are we okay with this data? What's this percentage chart about, right? So let's look at the next data. So we are finished with this. B took more time than G. With that, we got G is the second place. So we got first, second, and third. We still are to place fourth, the sixth, and the eighth rank. Now they say H took more time than A, while A took more time than E, which means among these three persons, E has taken the least time, so is the best possible rank among these three, and this is not so good performance. That means the worst rank among these three is given by H, and the middle value should be taken by A. Are we clear with this data, right? So we understand that H is among these three, H, A and E, right? E will be the first rank because least time, A will be the second rank and H will be the third rank among these three. But in reality, we don't have a first, second, third. That's already taken, right? What do we have? We have a rank 4, we have a rank 6 and we have a rank 8. Only there we can fit in. Can we put a rank 4, 5 and 6 here? Of course not. Only place we can put a 4, 6 and 8. So certainly E should be rank 4, A should be rank 6 and H should be rank 8. So H, let's fix it. That is rank number 8. A, that is rank number 6 and E, that is rank number 4. That's it. Right? Now if that is true, if what we just said is true, right, we should definitely be able to allocate certain scores for these guys, right? We look at certain scores for these two guys, right, these three guys. So the time taken by E should be between 320 and 420, not exactly 320, not exactly 420, greater than 320 but more than, right, but up to 420, that means less than 420, right? And if you're talking of the person A is 6th rank, so it has to be greater than, the time taken should be greater than 5th rank and lesser than 7th rank. So we are talking between 420 and 560. While if you're talking of H, H should definitely be greater than 560, right? So that's it. That we know the data. That's the data, and I think we can use that, to solve all the questions thereafter, right? So let's quickly take a look at the question. Who came fourth in the triathlon competition? That's easy. Fourth we found out is E, right? That's simple data. But we're going to use this data for a little more, right? We're going to fit this data even for the next couple of questions, right? So the next question is, who among the 8 competitors is the fastest swimmer? So let's come back to this. Who among the following is the fastest swimmer, right? If you're talking of the fastest swimmer, right? So we will want to take swimming, either the percentage should be less, for example, this person or this person or this person, right? Or even if the percentage is slightly more, right, the time taken should be less. For example, this person, right? But if you look at a person like, here, like D is taking more time as well as more percentage, right? So may not be the best bet, for us. So we might not want to check with a person like a D, right? So let's look at what we might want to check, right? Let's look at what we might want to end up checking. So let's start now with checking with their scores. So we are talking of H, right? Who came fourth in the, who came, the question was, who was the fastest swimmer? Who was the fastest swimmer? So if we look at the person C, the fastest in overall time, took 42% of 240 minutes. So in swimming, right? In swimming, the time taken by the person C would be 42%. So we are talking about 40%, 10% of 240. We know 240, 10%, that would be 24. So 40% would be 96. That means 42% should be approximately 100, right? The time taken by C in swimming is 100. Now we are trying to figure out if anyone is taking less than 100, right? That would be a good bet for us. If not, it's a bad bet for us, right? If you look at this person by name G, less total time and also less overall less percentage for swimming. So this was for the person C. Let's look at the person called G. So G is taking anywhere between 240 to 320 minutes, and we are talking of 20%, and 20% of this number, and what number are we talking about? 20% would be between 48 and 64 minutes. Now that's a good number for us. It's significantly lesser than 100. So 100 is ruled out, right? 100 is ruled out, right? If you're talking of the other people, right, definitely we'll not check for B, because B is 28% of a larger number compared to G, right? If you're looking at a person like D or E or F, they are higher percentage of a larger number, right? A is a similar percentage as G, but for a larger number, so we need not check, because we're talking of 20% of 420, which would be like 84 to 112. We don't need to check. And the last person in context would be H. Now H is 12%, right? 12% of some number. Now that's a dicey number for us, right? So H has taken 12%. What's 12% of 560? It's greater than 560, but even if I talk 560, 12%, what are we talking about? What is 10% of 560? That would be like 56. And if you're talking of 2%, right? 2% would be 11.2. So overall time taken by H in swimming would be something like 67.2. But hold your guns, this is not 67.2. This must be greater than 67.2. Why? Because the time taken by H is not 560, it must be greater than 560. You can easily notice it's 67.2, but greater than 67.2, while here it's between 48 and 64. So that will be the least time without any question, right? Who among the 8 competitors is the fastest swimmer, right? Among the 8 competitors, the fastest swimmer would automatically be G, right? So let's get back to the data, but before that, let's read the third question. Who among the 8 competitors is the fastest runners, right? Who among the 8 is the fastest runner? Let's use this data again, right? To find out who is the fastest runner, right? Swimming is fine. So let's move to running, right? Let's move towards this concept of running. Now in running, what's happening? In running, again, that's the last part that's given here. That's what is running, right? We have the context of running. Let's see what's happening with respect to running, right? Who is the fastest? Now there is one thing which is 8%. That's one, right? We are looking at something like a 15%, 15%, right? That could be a good bet to work with. We could be looking at a 22%, right? And these are some numbers that we should be looking at, right? And other values, right? That's 38% of a larger number. This is 44%. Okay, we might want to check with this as well, but we'll see, right? We will check. Let's start with this. Of course, not required though, but let's take a minute to just review this. If we are talking of C in running took 44% of 240 minutes. Now, sometime back we did 40% would be 96, right? So 4% is 9.6. So can we say like 10, right? So 10, so 96 plus 10, that would be like 106. Actually 105.6. That would be the time taken by C, right? C time taken is 106. And there's no prizes for guessing. I mean, if you're talking of the person B will definitely take lesser time than A. There is no reason to check it, but just to get you in perspective, to get you in context, right? I just wanted to show you what could happen, right? I will not check for G, though G is a small number, and because it's 62% of a larger number, right, compared to the person called C. Let's look at B. B is a nice number to look at. 22% of 320. Now, 20% of 320 would be 64. Another 2% would be 6.4. So let's make it round about 64, right, plus 6. So that makes it approximately 70. That's the time taken by B. Now, if there is somebody who takes greater than that, that's fine, right? That's good, right? It's not part of a question. If someone takes lesser than that, now that's something that we have to review. So let's look at this person who took 15% of 420. That's the person named F. Now that's exactly where the problem will start. If you're talking of 10% of 420, which is 42, and 5% would be 21. We are talking of 42 plus 21, that's 10%, and this is 5%. That gives it a total of 63, right? That gives it a total of 63. but the entire issue boils down to H here. The trouble creator is H, right? Because H is taking only 8%, right? So 10% of 560 would be 56 and 2% would be 11.2. So H took 56 minus 11.2. So approximately H took 45. But guys, no prize for guessing, right? It's not 45, but it's greater than 45. So greater than 45 could actually be equal to 63. Greater than 45 could be greater than 63, right? Or greater than 45 could still be less than 63. We have no clarity on this, right? How would this greater than 45 behave? H is taking 8% of a number greater than 560. We have absolutely no clarity whether it will be equal to close to 45 minutes, more than 45 minutes, less than 45 minutes. I mean, how much more than 45 minutes? We have no answer. Is it equal to 63? Is it greater than 63? Is it less than 63? We have no clarity. We have no clarity on this, and that is the fix that we need to fix here, right? So using that, what's the answer we need to delve at? So we looked at the question number 3, who among the 8 competitors is the fastest runner? We found that, it's definitely not going to be the person C. We found out that B was good. We found out that F was better, but H and F has a conflict because F is 63, right? F is 63 and H was greater than 45. Now we have a conflict between these two, so we cannot find the answer. The answer cannot be determined, right? Making sense? Good, superb. Let's go to the next question. Let's quickly look at the next question. Who among B, F, A, and D took the second highest time in biking? Now, this is a tricky question for sure. Who took the second highest time in biking? So you'll notice the first question is simple, super simple, and the next questions we're asking particular questions. So each in itself is a good question, and there's good amount of calculation also involved apart from the logic in the question, right? So let's look at second highest time in biking. So if you're trying to discuss, right, the timing in biking, we only have to look at these 4 and not anybody else, right? We already know C took 240 minutes, right? And B took 320 minutes. We know that F took, right? F came 5th and took 420 minutes. So we don't need the person C. That's not material for us, right? We don't need the person C. We need B. We need F. We need A. Now A, sometime back we noticed, right? A, sometime back we noticed from this particular data, A is taking rank 6 and between 420 and 560 minutes. We got to fill that 420 to 560, rank number 6, right? Rank 5, rank 3, rank 6, and finally D, right? D is taken 560, that is straightforward, and D is getting 7th position. So we don't need the positions here, right? Just letting you know, right? They were from that case let. So you more often than not, be using that data in all the questions in CAT. This particular graph, right, will be stationary for you. The rest of the data will be moving in CAT and most of the other exams, such as the online format. In the offline format, you need not worry in any case, right? So let's look now. Now, F is taking 55% in biking, right, of 420. So 55%, right? Let's start with that. F is taking 55%. 50% would be 210, 5% would be 21. So 210 plus 21, that's 231 minutes. That's the time taken by F in biking. That's the second thing, right? So let's look at D. D is taking 40%, that's an easy number. 10% is 56, 40% would be 56 into 4, that is 224 minutes. That's D, right? If you're looking at B, B is taking 50% of 320 minutes. That's 160 minutes. That's B, straightforward. So the problem starts here with A. Now A is not a number. A is a range of values. A is taking 42% of any number between 420 and 560. We have no clarity, but it's not equal to 420 and it's not equal to 560. Is any number between 420 and 560. Between 420 and 560. So let's take a look, right? So what is 40% of 420? Of what's 42%? Let's directly do that as well, right? So 42% we understand would be like close to 176, or you can do it the other way. The 40% of 420 is 168, right? And 2% would be close to 8.4 or just about 8. So that will give us a number like 176 minutes, right? It's 176.4, but we don't need an accurate value because we have nothing in the range of 176.4, right? If you look at the upper limit for A, it's 42% of 560. Now what's like 42% of 560? We can directly do it, right, and say, hey, listen, that value should be, right, 235, or we can do it as 40% plus 2%. 40% would be 224 and 2% would be like 11.2, so we can take it as 235 minutes. Okay, coming to one thing, a lot of people tell me, there's a calculator in exam. How often should we use a calculator? Or is it important to use a calculator? Normally I say yes, it's good to use calculator when the question is a calculation intensive question. Otherwise you'll have to know methods to do at least percentage calculations, right? Okay, never mind, let's do this question. So who took the second highest time in biking? So let's start with the lowest time. So B has taken the lowest time, right? That's certain. We know this data for sure, right? And the highest time could be either A, the highest, if A is 235, the highest time could also be F. The highest time would be F if A is less than 235, right? So if A is the highest time, right? If A is the highest time, right? In that case, the second highest would become certainly F, and then we will have the person D. This would be the order, one case. But we could have another case. F took the highest time, right? And lesser than F, we have D, and lesser than D, we have A, and then we have B. However, we missed out on one case. B is the lowest time. What couldn't it be this way? The F is taken the highest time, right? And F is followed by A, and A is followed by D, and D is followed by A. That means the lowest time is B and the highest time is F. So the question is, who's taken the second highest time? Now look at the answers. Look at the answers. Second highest time could be A. Second highest time could be F. Second highest time could be D. So you know the problem with this question. That's what I said. It's a little weirdo question. They've given a question like this when I picked it up from an exam. They said F or A and D or F. Now it could be both. It really could be both these answers. So that's a fix in this question that they should have done. But I've retained the question as it is. Most of the questions will be taken from exams, right? In what we will be solving, right? Okay, so before I move to the next question, right? Let's quickly review this question. This question was of these lines. There is, there are these 4 people. There are these 8 people, right? And out of these 4 of their, ranks and their time taken is given. And they given little details about the other 4. With that, we'll have to figure out who fits in where. Little bit of calculation. We have to find out who came 4th. That was the easiest question, right? Thereafter, we have to find out who is the fastest swimmer. We easily found out who is the fastest runner, right? And here we are not exactly able to find out because of the simple reason that it was a range of values for age, right? And finally, who took the second highest time? Like I said, there was a problem in this. Very easy question, right? These are some kind of question that you should always try to attempt. So just think of those caselets, and you'll be good to go, right? Yeah. So before we move to the next question, for most of you, there will be a very less time frame left for you to take up the CAT exam, right? So what is that I would recommend, right? What is that I would recommend? Now, if I were a student, if Sanjeev were a student and giving CAT on the, by the end of November, right? That's on 25th of November. What would I do in the given, assuming that I have about 30 days left, or I have about 15 days left? What would I be doing if I had 7 days left? And what would I be doing if I have 2 days left, right? What would I be doing in case of the examination, right? The first thing, or the check boxes, these are the check boxes that you will be doing, right? Definitely you got to do the CAT 2017 paper, and that's a must, right? Compulsory. The second thing, you will do all the old CAT papers, all the old CAT papers available, right? All the old CAT papers available, right? Specifically, please look at LR, DI, and Quant, right? Please look at these two sections. You know what? There's a certain philosophy that CAT has, and let me be frank with you. None of us can actually match up with their philosophy. We try to make questions. We try to make questions which are good, right? But we cannot exactly map. That's the reason I don't tell you this question is going to come for CAT. What I will definitely tell you, this logic will be repeated, and you will see this logic. For example, the sliding rule. I can give you at least 20 instances in the CAT examination where that sliding rule would have been used, right, in data sufficiency or in other questions, right? That's exactly how CAT works, right? They work on some philosophy. We don't know the philosophy that they work with, but we can come close to thinking because we've been in this field for quite some time, right? Okay, so all the old CAT papers, specifically Quant and LRDI, right? This is something that you must do, all the old questions. Now, if you have time beyond that, right? Like if you have just 2 days, this is what you will do, right? There are 2 papers on CAT 17. If you have like 15 days, right? This is what you will do, right? You don't know the topics, don't worry. Just look at the question, right? Try to solve it. Give about 2-3 minutes for a quant question, and give about 8 to 10 minutes for an LRDI. And if you don't get it, then you go to the solution, right? Check for this. Once you're done with this, then you can check your mocks, right? In between, whenever you find that this is too much of a task, right? When you're going through, right? Do refer to some videos, right? Do refer to some videos which gives you a detailed solution. You will be able to grasp the concept better and quicker with videos. There's no questions asked. There's no questions asked. Trust me on this, okay? If a lot of people, a lot of people debate with me on this topic, right? Why is videos the best thing around, right? Okay, that's wrong spelling. That's wrong spelling, right? Okay, so we have videos. Why is videos better than, right? Why would I say videos are better than a classroom, right? Videos need not be better than a classroom, but trust me on this, right? You can pause and play the video n number of times, right? Second, take a book and try to memorize the book, and take a video or a movie, right? You'll at least get the essence of it. And that's exactly what you need to get. You don't need to know everything here. What you need to get an essence, right? You need to get the essence or the flavor of the entire thing, right? Watch videos, right, which gives you further concepts that will help you. It could be an LRDI, it could be a quant, even on verbal. If there are shortcuts, go through it, right? Trust me, it will help you. Okay, now there are 2 words of caution, right? One, if there are answer options, right? There are answers with options, right? Try to use them, right? Try to use them, right? That's good. If there are answer options, right? Whether it's English, whether it's quant, it's LRDI. If there are no answer options, what do you do, right? So you have the short answer type question. Short answer type question where you got to type, you got to input the values. What are you going to do, right? please attempt it. It does not matter whether you get it right or wrong. CAT is not going to negate marks for you, right? Nor is it going to be used for your scaling. So please attempt all those questions. Just place in some value in that. It does not matter what value you place. Even if it is wrong, it's fine. However, if you're solving them, you cannot use answer options. There's certain methods, right, that we'll tell you over the course of these sessions or these video lectures, that you will get to know what, for example, in a progression, what are the values that you can substitute, right? What are the values you can substitute? Or let's say a question is on time, speed, distance, and there's a short answer type. What are the values that you can start thinking, right? You substitute back into the question because you don't know the answer options there, right? Or for example, we could take a topic like percentages or ratio proportion, right? So each or simply a profit loss discount and a simple interest compound interest. There are certain values that you can start looking. So there are methods and there are values we'll be telling you over the course. Be hooked on, and this is exactly, this is what you will be doing over the next, in case you have about 30 days. If you want to stretch, I think this could be done even in 7 days, right? Probably online, you can ask us. We can easily be giving you about 20 plus old CAT papers, right? So that I'm essentially saying that on an average you can do about 2 papers easily a day. A paper would take you about 2 to 2.5 hours, and the analysis should take you easily about 5 to 6 hours, because you're not just doing the paper, you're going to review each question, right? So on an average, if you're taking 8 hours a day for 8 hours a mock, right? So we are talking of 21 old mocks. That means about 168 hours. So just review, or 168, maybe a ballpark figure. I would not say 168. I would say about 180 hours, right? That would be a ballpark figure. Now you need to think whether that's okay for you in 7 days, right? Right, or whether that's okay for you in 15 days, right? So in 7 days it will just not be possible, because this is possible in 7 days. 24 into 7, that's 148. So just think how you're going to manage, right? And during the later part of the course, it will not take 8 hours. So initially it will take 8 hours because you're just starting off, right? But if you have a 30 days, this entire thing should be done in 30 days, right? This entire thing should be done in 30 days. And I think if you have a little more, close to 30 days, I think this entire thing can go ahead, right? Okay, so that's what I would say for a session plan, in case you have. And please keep in mind, LRDI and quant can be deal breakers, right? My expectation is they'll be deal breakers this time, right?
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free, AMC.